Assalamu alaikum everyone. Hope all of you are doing great. In today's class, we'll discuss about Hamming code. We all know that Hamming code is a fundamental type of channel coding. It is basically a linear block coding technique. Here, the message is divided into fixed sized blocks. So, without any further ado, let's get started with our process of Hamming code. At first, we have to remember a small formula here, which is 2 to the power r is less than or equal greater than or equal m plus r plus 1. So what are they meant by? Here the r is meant by redundancy bits and the m is basically the data bits or the data words. So in together this is code word. So our code word is combining with the data word and the redundancy bits. So how can we determine how many redundancy bits we need to add for reliable communication? Question can be arised. So for this question the answer will be this formula. So let m equal to 7 or the data words is 7 and the r is equal to 2. So 2 to the power r equal to 2 to the power 2 4 and the m plus r plus 1, which is basically 7 plus 2 plus 1, altogether it results to 10. But the formula or the equation is not matching, that's why that is not reliable. But in case if the r equal to 3 here, it is also becoming 8, which is also not defining the formula. But if the r equal to 4, then 2 to the power 4 equal to 16. Yes, now it is aligning with the formula. So if the redundancy bits is 4 bits or 4 digits, then the formula will aligned and it will be a reliable communication. So in Hamming code we can see even parity and odd parity. So what is even parity and odd parity? In even parity we need to take the number of 1 is even. We need to make sure the number of ones is even in the entire string. And in the odd parity it will just be the reverse one. The number of ones will be odd in the entire string. Let us now consider an example here. We will now finally stepping into the process of Hamming code. So let us consider the data word is 1 0 1 1 0 1 1. Okay, let's create a table 1 2 3 4 5 6 7 8 9 10 and 11. So why we have taken 11 cells here? Because we are now doing 11 digits Hamming code. Normally we see 7 digit Hamming code, like there were 4 data words and 3 redundancy bit, but in 11 digit Hamming code the cases are different. Let us see. So we know the parity bits maintain a form which is 2 to the power I, where I equal to 0 1 2 3. So if 2 to the power 0, this is 1, this is 2. First we should number the cells 6 7 8 9 10 and 11. So this is 2 to the power 0, that will be a parity cell. This is 2 to the power 1, another parity cell. This is 2 to the power 2, another parity cell. And lastly this is 2 to the power 3, another parity cell. There can be no other parity cells except those four. So now let us put the data words into the data cells. So in number 3 the first data cell, then in the 5 the second, then it will be the third, fourth, fifth, sixth, and the seventh one. So we have written the data word like the 1 here, the 0 here, the 1 here, then the 1 is on the 7th position, then 0, 1, and so on. We have put blanks here for the parity bits. Now let us write something interesting. 0 0 0 1 0 0 1 0 0 0 1 1 0 1 0 0 0 1 0 1 1 0 0 1 1 1 1 0 0 0 0 1 1, sorry, 1 0 0 1 1 0 1 0. So there are 11 bit streams: 1 2 3 4 5 7 8 9 10 and 11. 1 1 11. So let us considering the ones from the first row. So for the P1 we will take the first one, so it will go to the 1, then the third one, because in this position the third one comes, then the fifth one, then the seventh one, then the ninth one, and finally the 11th one. Now let us consider the second position here. So in the second position we'll get the 1 first number, then the second, then the, sorry, my bad. So in the second position we are seeing 1 in the second row, second bit stream, sorry, so we'll consider 2 here, the third one also, then all the way up to the sixth one, 7th, 10th, and 11. Then let's go for the P4, I guess, P4. For the P4 we will take the third position here, so it starts from the 4th, then 5th, 6th, 7th. Okay, that's all. And for the 8 we are getting the 4th position here, so it starts from the 8, 9, 10, 11. Now we'll do some magic. So in the 1th position, 3rd position, 5th position, 7th, 9th, and 11th. So in the 1 position we are seeing the P1, so we will determine the P1. That's why we are marking the 1, we will marking the 2, 4, and 8, because in those position we will get the parity bits. So in the 3rd position we are getting 1, so writing 1, then it will be in XOR form. In the 5th position we are getting 1, in the 7th position getting 1, in the 9th position we are getting 1 again, and in the 11th position we got 1. So what will be the value of P1 then? See, we are getting 1 2 3 4 5 ones here, so 5 is an odd number, So in order to maintain the even parity, for even parity, we have to consider p1 as 1. So there will be total 6 ones, and 6 is a even number, so even parity checked, there is no error. Okay, then in p2 case, in 2 we have to find out the second parity. So starting from the third bit, so it is 1. In the sixth we can see 0. In the seventh we are seeing again 1. In the 10th we are seeing 0 again, and in the 11 we are seeing 1 again. So what will the p2 see? We are seeing 1 2 3 ones here, so 3 is an odd number. In order to maintain the even parity, it will be 0 here, because p2 will be 0, sorry, p2 will be 1 here. So now there are 4 ones, so 4 is a even number, so even parity checked, no error. Then in the p4 case, we will find out the p4, the fourth bit is the parity, third parity bit. So the fifth number is 1, then the sixth number is 0, and the seventh number is 1. Okay, so what will be the value of p4? Then we are seeing 2 ones here, so 2 is a even number, so even parity is already checked, so the p4 will be 0. And then at last the p8, or the fourth parity bit. For the fourth parity bit, we have to consider from the ninth position we are seeing 1, then the 10th position 0, 11th position 1. So already there are 2 1, so 2 is a even number, even parity checked, so p8 will be simply 0. So yes, we have already found out the parity bits here. So altogether the code word will be 1 0 1, the 8th number will be 0, 1 0 1, the fourth number will be p4 equal to 0, then third is 1, then the second position there will be p2, so p2 equal to 1, and the first position p1 is the 1. So this is our code word. This is our encoding part of Hamming code. Now we will start the error detection part. So this is our received code word, but we can get some noise. So let us consider the received noise signal is or the code word is 1 1 1 0 1 0 1 0 1 1 1. So let us bound it into a shell. Okay, there are 7 cells here. So 1 2 4 5 6 7 8 9 10 and 11. Okay, so again recalling the 2i, so 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3 equal to 8. These are the parity bits. So let us introduce syndrome here, S1. So in S1 we will consider the previously written 1 3 5 7 9 11, which is seen on the P1 part. So 1 3 5 7 9 11, 1 3 5 7 9 11. So in the first we are getting the 1, in the third position we are getting the 1, in the fifth position we are getting the 1 again, in the seventh we're getting 1, 9 we're getting 1, 11 we're getting 1. So we can see 6 ones here, so even number of 1 we can see, so the S1 will be simply 0, no error. Now for the S2, For the S2 it will be 2 3 6 7 10 11. So 2 3 6 7 10 11. So in the second part, second position, we are seeing 1. In the third position again 1, sixth position 0, 7th position 1, 10th position 1, and 11th position 1. So here we can see 5 ones. So yes, there is a error here because 5 ones. So 5 is odd. We need even. So it is not equal to 0. So S2 will be 1. That means there contains some error. So what will be the S4 then? For S4 we will consider 4 5 6 7. 4 5 6 7. We are basically doing the XOR operation here. Okay. Now for the 4 5 6 7, the fourth position we are seeing 0, the fifth position we are seeing 1, sixth position we are seeing 0 again, and seventh position we are seeing 1. So the S4 will be, if we XOR them, it will be 0. So no error. Then at last for the S8, it will be 8 9 10 11. 8 9 10 11. So in the 8th position we are seeing 0, 9th position we are seeing 1, 10 and 11 both 1. So if we XOR them, the result will be 1. That means there contains error. Okay, now we'll simply just write out the 1 0 1 0. It means in the descending position S8 S4 S2 S1. So it will be 1 0 1 0. So this is in binary form. If we convert it to the decimal form, it is simply in the 10th position where we have to replace the digit. So in the 10th position we are seeing 1, so we will replace 1 with 0. So replacing 1 with 0, we are getting 1 2 3 4 5 6 7 8 9 10 and 11. So that will be 1 1 1 0 1 0 0 1 0 1. So 11 10 9 8 7 6 5 4 3 2 1. Yes, so this is our final answer. You can see the answer is equal to the received code word. The received code word was 1010 1010 111. So this is 1010 1010 111. Yes, the code is now correct. That's all for today's class.